Okay, so we're going to start by constructing trapezoid Fred right here. And you've got segment FR right here. I want you to grab a point, put a random point there above the segment, and we're going to name that not C, but D. Very good. D, delta. So select your segment, FR, and select your point, delta, and construct a parallel line. We know that, again, for any, well, line, or in this case segment, and point not on the line, we could draw one parallel. There it is. Now, we're going to put a random point right here, and we're going to call that E, echo. And now you have your trapezoid. Now, if you can't see it, right there, can you all see that? Right there. We're going to hide our construction line.
I have a question.
Yes, Luke. D is a random point. E is random, but it's on that parallel line. That's the key. Now, everyone, this definition is specific for or it's a little unusual. Remember before we said we would say things like an isosceles triangle has two congruent sides, but it could have three. This figure has one pair of parallel sides, but only one. All right, so let's put in the parallel arrow. This tool I put for you, snap from D, snap to E. From F, snap to R. So that's going to indicate your pair of parallel sides. Now I know what some of you are going to say. Somebody's going to do this and say it messes up. And you know what I say? Okay. Don't do that. Yeah, I know it'll do that. I mean, Sketchpad doesn't know what you're thinking, so please be sensible. Now, the two parallel sides are called bases. So I want you to, we're going to label them B1 and B2 respectively. I click on it, comes up J. I double click on it. Now watch carefully. Lowercase b, use the bracket. The left bracket, 1, close bracket, and that's going to drive a subscript. So I'm going to put a B2 up here. That's lowercase b, bracket 2. Done. Now those two are your bases, and the other sides that are non-parallel, the non-parallel sides, and I'm going to write this over here just in case you were making notes. Remember, you can use this on your test. Non-parallel sides are what? Are legs.
Is that B2 up there?
That is B2, correct, because these are the two bases. Now, it's arbitrary which one is which, and as a reminder, I could have, my bases don't need to be top and bottom, they could be vertical. The bases are the parallel sides. And we're going to do a little bit more with this before we move on. And the one thing we're going to do is we're going to construct some midpoints. So I want you to select construct midpoints. On both, yes. And we're going to call those M and N respectively. Must be a cap. M and N. Hunter.
Yeah.
Please.
You doing it.
Yeah, no, I know. And I'm going to connect those, and I'm going to make this red just so it stands out.
Wait, so you just put a random line through the middle?
Well, it's not a random line. You're connecting two midpoints, so that makes it not random.
How do you make the midpoint?
If you select the segment, you construct midpoint right there. Now, in order to designate it as a mid, or these points as midpoints, I want you to use your little side ticks. Watch, this time I click from D to M, from M to F. Guys, Calm down over there. I get excited by math too, but that's, I don't know about that much. Side tick 2. So I just want you to snap some tick marks. Little tiny tick marks. Because this tells you that M is a midpoint and N is a midpoint. Now, this piece right here is going to be called a midline. Now, we should label that, we could label that with a lowercase letter, but I just want you to write the word midline, or mid-segment. That's more accurate.
Wait, D and F, DF isn't congruent to ER? Like,
DF is not congruent to ER, correct. But DM is congruent to MF. EN is congruent to NR. They are two midpoints. And the other two sides, the two legs are not congruent. We'll get to the case where they are. That'll be the isosceles trapezoid. But we're not there yet. And that will have even more special properties. Now the mid-segment has a couple interesting properties. The obvious one, what appears to be true? What appears to be true, we're not going to prove it here because for interest of time.
looks
But
like a trapezoid.
now what it looks like it's parallel. Very good. And that is true. This is parallel, so I'm going to put the parallel arrow in there as well. Now we could prove this. And we could prove, the one way we could prove this is drawing this diagonal. We could split the figure into two triangles. And that mid-segment would be composed of two mid-segments of two triangles. But we're not going to do that today. That's we'll save that for a book exercise. Right here, instead, we're going to do something more interesting. We're going to measure. Select the two bases and measure your length. Now your length comes up here.
Wait, how did you do that?
Select. Now you're in a different version. You may have to go under calculate. But I'm going under measure. And you see where it says length?
Yeah.
You got it?
Just click this segment. And then you do that.
Now, again, you're going to be in calculate again. I want to take these two numbers and find their average. When I average two numbers, I'm adding two numbers and dividing by 2. So, go to calculate. I go to, mine is under measure. And you all have this calculator? Everybody got that?
Yeah.
All right, so put in the left parenthesis, B1 plus, click on the B2, right parenthesis, divide by 2. And that's going to give you the average of these two bases.
Do that one again.
Left parenthesis, B1.
Why don't let me type in B?
No. Click on the measurement of B1. Come on, how many times have you done this, Hunter?
And what?
Plus B2, close parenthesis, divide by 2.
Type by 2?
Yes. It should come up looking like this. Now again, you could change your figure.
Why do you have to put the average?
Well, it's funny you should say that. Now, I want you to select the mid-segment and just measure it. Heavens to Murgatroyd, what have you noticed?
The same.
Whoa. Hey, what do we see?
The same length.
What's the same? The
average.
mid-segment is the same as what?
The average.
The mid-segment is the average of the bases. It's right there. That is beautiful.
Wait, how did you get the big segment?
I just selected it and measured it.
Why did you do that?
Oh, it does, Luke. It does. All right. Now, say, Luke, if you can't, if you fall behind, that's all right. Just stay on whatever page we're on. And if Alex doesn't keep you up with us, I'll be glad to come around and help you after we get to the end. Thank you. All right, next page. Isosceles trapezoid. Oh, But Alex, I think you're going. Alex, it's for you.
Oh.
Oh, guys, come
The
on.
blue pass.
It's a blue pass. Crying out loud. Draw a random segment. Draw a random segment. I'm going to make it blue. That doesn't look blue.
That looks blue. Oh, there's the
I'm going to make a random segment here, and we are going to construct an isosceles triangle. And this isosceles triangle, QWZX, what a funny set of letters. So, not A, I'm going to make this Q, oops, capital Q, and I'll make this the big W. We're going to do this one a little bit differently. We are going to construct angles. We're going to start by making an angle. You all see this red angle in the corner. Now, our job is to translate. We're going to make that red angle occur here at Q. Remember, this thing can be moved around, this base, this blue base. If you want to, you could call that B2, but we already know what the bases are. So now, in preparation for recording an angle, double click on Q. You want to double click on Q because you want to generate an angle congruent to this red one. Now you're going to record the angle. Select B, A, T, BAT. In that order. Transform, mark angle. Did you get that, Luke? B, A, T. Transform, mark angle. Now you need something to rotate. You've marked the angle. You've marked where you want to rotate around. So go pull up your ray tool, snap a ray from Q to W while it's still highlighted. Transformers, rotate by marked angle. There it is. That's a boom shakalaka. Now I'm going to hide this ray, the one that I rotated, but this is all I've got. Now I'd like you to mark this angle so we can keep track of it. Like this. Well, then you is it a 90-degree angle? I would redo it fast. Then what I want you to do, I want you to click 1, 2, 3. I want you to mark this with the red angle in the corner at Q. Just mark the right angle, the right angle tool. All right, now I'm assuming I might lose some of you, and that's okay. If I lose you, you'll get picked up when we come back around at the end of class. Okay, now I'm going to draw a ray with the same red angle at W. So double click on W. W. But I want the angle to open the other direction. So how about if we just record it in the other direction? T, A, B. Transformers, mark angle. Bloop. And I'm going to draw that ray from W. Oops, I need the ray tool. From W to Q. Transformers, rotate by marked angle, and there it is.
Oh.
Tight, you might say. Now, I'm going to mark the red angle right here. Okay, before I go any further, tell me, everyone, what figure do you see that you remember from chapter 4? What kind of triangle? Isosceles. That's exactly right. If you're looking at this figure right now, you are seeing an isosceles triangle because it has two congruent base angles. So, well, that's true. That's very, very true. So what we're going to do is we're just going to take this isosceles triangle and we're going to make a chop top here. Oh, we're going to chop the top. So put a random point here on this ray. And what's the name of our isosceles triangle? QWZ X-ray. So we're going to put an X here. And I want you to select. Again, I want you to select the blue base and can select the X. And what do you think we're going to construct?
Parallel line.
Parallel line. Yeah, that's... Do you see a trapezoid now?
No. Yes.
Oh, I see a trapezoid. Come on, guys. I see a little Tommy trapezoid right there.
Little Tommy trapezoid. Little Tommy trapezoid.
So what's the name of this point? It's not D, it's Z. Very good. Now, we're going to clean this up a little bit. Well, I'm going to replace this with a segment. Remember, and when you do that, yours turns your construction line dashed. And before I do anything else, I'm going to put my little parallel arrows in. From there to there. From Q to W. Nice. So just like before, I've got these two parallel lines. This time, I'm going to draw on the sides, but I'm going to draw them in with these little tick marks because these two sides are now congruent. Now, we haven't proven that, but they are. I'm going to make, and you could color the sides at will. I'm going to make mine purple. I like the bases in blue because I like the way that sounds. Blue bases.
The interior?
Well, no, we're not worried about the interior yet. Now, again, I'm going to caution you not to do this. See, that's shenanigans. That just messes up your figure. Just don't do that. You know, you have to have some kind of limits on this figure. The sketchy pad isn't perfect. It's pretty darn good. But we're going to see some other properties with this before we move on to the next page. Now, I'm going to take the angle tool and I'm going to put the blue angle up here at X. Now, when I do that, I click on X. Now, be careful. Right now, don't click on this whole line. I back away. I have to click on the segment and then there. Now, I just made up this red. I know there's a relationship between the red and blue angles. They must be, it starts with an S. They are?
Similar.
No. Supplementary because they are consecutive interior angles. If the lines are parallel, consecutive interior angles are supplementary. So, if this blue angle is supplementary to this red angle, and I've got a red angle here, what color angle goes here? Blue. Because they... Guys, supplements of congruent angles are congruent. Look at that. Chapter 2 coming back right at you. In an isosceles trapezoid, both pairs of base angles are congruent. The red ones and the blue ones. Remember, I could turn the figure, I could just as well do this with the figure. And that's still, this is again an isosceles trapezoid. We're almost done. We'll just explore one or two more properties. And I want you to draw on a diagonal. Diagonal. I don't know what color. I'm going to make mine green because I feel like it. And I want you to click on or construct a triangle here. And it's got to be very lightly shaded. That's too much.
We just draw a...
Just draw a diagonal. Now, I'm going to draw the other diagonal. And I'm going to select, I'm going to shade in this triangle. 1, 2, 3. Construct triangle interior. But I'll make this one a different color. So now, if I flip on these two triangles, how would you describe these two triangles? And it starts with a C. Congruent. Do you know why they're congruent? Remember, side Side, the red angles. Why? I heard it. What was it? Side angle side. Well, since they're congruent by side angle side, then I can do this. Then this diagonal is congruent to this diagonal. So the diagonals of an isosceles trapezoid are congruent as well. Anybody remember the diagonals of a square are congruent? How come this isn't a square? Because
all four sides are
yeah, but just about the diagonals though. The diagonals are congruent, but they don't do what?
right angle.
Nah,
They're not parallel.
nah,
Perpendicular.
no. It's neither are they for a rectangle. Diagonals of a rectangle are congruent, but they also, in a parallelogram, they bisect each other. These do not bisect each other. They are congruent, but they do not bisect each other. Excellent. All right, we're done with this page for now. So, see, kite, we're coming back to the kite, Charlie Brown, but we're going to skip ahead. There's 3 on the bottom where it says plot points. Skip to the first one, and I'm going to let you do that one. We're going to do this one together. And let's do some math. Graph. Define the coordinate system. When you define the coordinate system, you're going to get all this ugly stuff here. Yuck. So graph. I'm going to hide the grid. Graph, define coordinate system. Now, don't snap these. Do not just snap these points. You're going to plot them. When you plot them, it goes like this. Under graph, plot points.
Wait, which one are you on?
I'm on plot 1. We skipped kite.
How did you make it do that?
Define coordinate system. -1, tab. -1. And I hit plot. All right, to fill in the x and the y, I type in 0, I tab 3, I hit return, that's plot. 3, that's number, you're going to plot points 1. Tab 3, plot. You're going to do the other 2 on your own. Then finally 4, tab -1, plot, done. Now, these 4 points just appeared. You have to know where they are. This is J. Comes up A, but that's going to be J. L is on the y-axis. That's 0. I'm sorry, that's K. L is here, 3, 3. And M is 4, -1. Now you do recall that you can change the size. You can use that point right there to change the size of your picture if you like, to change your scale. And we're going to draw the figure. Connect the dots. J, K, L, M. So I guess I could have left if you left the grid on there, you might see this a little more easily. What's the slope of KL? 0. What's the slope of JM? 0. 2 lines have the same slope. They are parallel. So I'm going to put my little parallel ticky marks in there. Where's my parallel arrows? From K to L. Snap, crackle, and pop. There you go. J to M. Done, done.
There's like 2 tick marks.
The one that says, no, the one, sorry, parallel arrows. Parallel arrow. Now, I'm looking at this and I say it is a trapezoid because there's no way that this side is parallel to this side. One's positive and one's negative. However, there's something else going on here. If I looked at this, can anybody tell me without pulling out a calculator how long this side is in radical? I'll give you a hint. Use radical form.
2.5.
No, radical form.
4.
What's the vertical distance between here and here? Vertical distance rhymes with door. 4. What's the horizontal distance?
1.
What's 4 squared?
2. 16.
Guys, what's 1 squared? 16 plus 1?
17.
So the side is?
17.
Guys, hey, wasn't this just a chapter ago? Come on. Now, it's slightly bigger. It's slightly bigger than 4. I don't need to know what it is.
4 radical 1.
How long is this side?
4 radical 1.
It's not 4 radical 1. You can't, they don't split that. No, 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 no. Radical 17 is not 4 radical 1. Danger, danger. Because 4 radical 1 is 1. I'm sorry, it's 4. It's 4 times the square root of 1, which is 1. Can't split that way. It's square root of 6. Now, I don't care what the numbers are, but it tells you something that this is what kind of a trapezoid? Isosceles. So, if you were classifying this figure, I would say that this is an isosceles. Yes. Oh, didn't mean to shout. Sorry about that. This is Isosceles Trapezoid. Except you could do it without misspelling. Awesome. All right, you've got 2 more of these to do. I'll let you do those on your own. But wait, there's more. All right, we've got this. So you got these 2. You can do the same thing. Go back to Kite. We didn't do the kite yet. Now, you've got these 2 little dash segments here. I just want you to put random points in there.
On both of them?
Yeah, and I want you to connect the dots. So you can change the shape like this. I put little stops on it so you can't do silly things. You can't put them both on the same side. Now, I could draw, I want to put a little right angle symbol in here. Because this is the most important, well, one of the most important properties you'll notice. The diagonals of the kite are perpendicular. What kind of triangle do you see right here? A right triangle. Construct. Triangle interior. Now make sure it's a nice light color. And if I were to do this, transformers, if I were to reflect it, is it going to fit? What does that mean when it what does that mean about the 2 triangles? They must be, you can use the C word, they must be congruent. They've got to be congruent. Because in the truest sense of congruence, they're exact fits. You know, I could orient, I could flip one over, I could rotate it, I could translate it, and it would map onto the other one. Now, it is true that I've got 2 pairs of congruent right triangles, and this diagonal here bisects the other, is the perpendicular bisector of the other diagonal. How about the horizontal, the one that's horizontal here? Is that a perpendicular bisector?
Yes. Yes.
Perpendicular bisector. I like half of that definition. It's perpendicular. It is not, okay, only the vertical one in this case is a perpendicular bisector.
But we just learned that.
Now, the other ones, they're both perpendicular. Listen to what I'm saying. This diagonal is perpendicular and cuts the other one in half. The horizontal one is perpendicular but does not cut the vertical one in half. Because the definition of a kite, the textbook definition that you will know, is this. That you have 1 pair, and put these tick marks in, 2 pair of adjacent congruent sides. That's your kite. I like that. That's a beautiful kite. Now, your job, before you turn this in, I want you to construct your own kite here. And I'll give you a hint. Construct it with diagonals. It's the easiest. And then I want you to finish up these 2 and then send it in. And I think we're done.